This video goes over section 19.3 and it's part 2, and we are using graphing quadratics to solve quadratic equations. And so first I just want to point out a couple of definitions that we will need and some formulas as well. And so standard form of a quadratic looks like ax squared plus bx plus c equals 0. And when we have a quadratic in that form, we're going to use a vertex formula to find the vertex. And so how we do that is we find x equals the opposite of b over 2 times a. That's going to give us the x value of the vertex. And we just plug that in to find our y. Okay, so taking a look at example 1, the first thing we want to do is find our vertex. So we're going to identify our a, b, and c. We already have one side equal to 0, and so our a is the number in front of x squared, so 1. Our b is the number in front of x, so -2, and our c is our constant. And we're looking for the x value of the vertex, so we're doing opposite of b, so our b is -2, so our opposite of that would be 2, over 2 times a. So we're looking at 2 over 2, so our x value of our vertex is going to be 1. I'm going to go ahead and plug that in here. And then to find our y, we just plug that into our equation. So 1 squared minus 2 times 1 plus 3, and you can type that in your calculator or do it in your head. Either way, you're going to get 2. So we're looking at the point 1 comma 2, and we're going to go ahead and plot that on our graph. It's going to be right there. And then we're going to do 2 to the left, just as we did in part 1 of this lesson. So we're going to do 2 and 3, and we're going to do 2 to the 2 to the right and 2 to the left. So I'm going to plug in my 0. So I do 0 squared minus 2 times 0 plus 3. And that is going to give me 3. And because we talked about this in lesson 1, I am not going to plug in 2, because if 0 is 3, then 2 should also be 3 because the quadratic is symmetric. So now I'm going to plug in -1 squared minus 2 times -1 plus 3. So that is 6. And so I'm going to go to -1, 6. And I'm going to go ahead and use my property of symmetry again. And so I also have 3, 6. Now, keep in mind here that we are only interested in where this graph crosses the x-axis. And this one does not. In that case, we have no solution. That happens sometimes with quadratics. It's okay. Let's go ahead and take a look at example 2. All right, we're going to start this one off this same way. We're going to identify our a, b, and c. So a is 1, b is 2, and c is 1. And we're going to plug those into our vertex formula. Opposite of b over 2 times a. It's going to give us a vertex of -1, comma. Let's go ahead and plug it in and figure out what our y value will be. And that's going to be 0. So we have a point at -1, 0, and I'm going to go ahead and plot that and put in my axis of symmetry. And when you get in the habit of doing that, plotting that, putting in your axis of symmetry, it makes making that table so much easier because you just use the property of symmetry. I'm going to use 0 and 1 and -2 and -3. I like to plug in 0 because it's just easier to plug in. And also, if you haven't noticed this yet, when you plug in that 0, this value right here is always going to be your answer. That's not a coincidence. So I'm going to plug in 0, and I'll show you what I mean. 0 squared plus 2 times 0 plus 1 is 1. It's always that c value. So that's 1, and I'm going to go ahead and reflect that using my property of symmetry. So I also have a point at -2, 1. And now let's plug in -3. So -3 squared plus 2 times -3 plus 1. So I have 9 minus 6 plus 1. That's 3 plus 1, so 4. And so we have a point at 1, 4. And I'm going to use my property of symmetry to reflect that. So I'm also going to have a point at -3, 4. And I connect my points. There's my graph. Remember, I'm only concerned with where that graph is crossing the x-axis. And at this one, or on this one, it's only crossing at -1. So our solution is -1. So if you recall from previous lessons in this unit, we said that a quadratic can have 0 solutions, 1 solution, or 2. So far in this lesson, we've seen a one with 0 solutions, and now with 1 solution. All right, let's take a look at example 3. The first thing we're going to do is identify our A, B, and C. So A is -1, B is 5, and C is -4. X is opposite of B over 2 times A. So -2.5. It's going to be, that's kind of interesting. We haven't done one like that. I'm sorry, that's actually positive 2.5. That's okay. We can easily do this, no problem. So we're going to plug that in to find our Y. And we're going to get 2.25. Now, don't let this freak you out because we're going to use integers for our table and everything will be A-okay. But for my middle point here, I'm going to do 2.5, 2.25, and let's go ahead and plot that. So it's going to be halfway between 2 and 3 and just a little bit above 2, so like right there. I'm going to go ahead and put in our axis of symmetry. I'm going to use 3 and 4 and 2 and 1. So I'm plugging in integers because I personally don't love working with decimals. So we're going to plug in integers. So we have -3 squared plus 5 times 3 minus 4. That's going to be -9 plus 15 minus 4. And that's going to give us 2. And we also have a 2 at 2 because they're symmetric. And then we're going to do 4. It's -16 plus 20 minus 4, and that's going to give us 0. And that means we're also going to have a 0 at 1. So see, it all worked out okay, even though we had a decimal to start with our vertex. Remember, we're only really concerned with where it crosses the x-axis, so our solutions are 1 and 4. All right, I am going to leave example 4 for your teacher to show because it is a lot easier to do when you have the calculator in front of you and you're doing it. And so I will leave you there. Good luck.